This JMP demonstration shows how to perform a randomization test in JMP Pro. I'm using the popcorn data from the sample data library. Randomization testing, also known as permutation testing, is a resampling method that estimates the sampling distribution of a statistic in order to generate a confidence interval and a p-value for a hypothesis test. Randomization testing is available in analysis reports in JMP Pro. Here, we'll do a randomization test on the effect of the independent variable oil amount on the dependent variable popcorn yield. First, we'll create our randomization column for the independent variable by right-clicking on the column header for oil amount and going to New Formula column, Random, and Sample with Replacement. This creates a new formula column in the data table that randomly assigns each row to one of the two different oil amounts, little or lots. Now that we've created our randomization column, we'll conduct a hypothesis test of the effect of oil amount on yield. We'll go to Analyze, Fit Y by X, and place oil amount into the X factor role, and yield into the Y response role. Under the red triangle, we'll select the Means ANOVA Pooled T option to conduct a pooled variances t-test. In our results table, we'll right-click on our statistic of interest. Here, that's the difference between group means, and select Simulate. We'll choose oil amount as the column we want to switch out, and the new randomization column, resample oil amount, as the column that we want to switch in. We'll next set our number of samples or randomizations to run. We'll do 1,000 right now. And for reproducibility, let's set a random seed. When we click OK, JMP simulates 1,000 analyses, each with a different random assignment of rows to oil amounts. The results are presented in a new data table. We can use the distribution platform to explore the results for our statistic of interest, the difference in yield across the two oil amounts. We have a histogram and summary statistics of the simulated differences, and under Simulation Results, we have confidence intervals and empirical p-values. The empirical p-values represent the proportion of simulated differences that were as extreme or more extreme than the difference that we actually observed. For example, our two-tailed empirical p-value of 0.521 indicates that 52.1% of our simulated differences in means were more extreme than the difference we actually observed, 1.05.